If you are new to my channel, please consider subscribing my channel and support me. And in today's video we are going to discuss about data types. So in verilog we are having various kinds of data types. So among them the important data types are wire and reg. Okay, wire is also called as net. Okay, net and reg. Okay, these two are the two main data types in verilog. So apart from these two we are also having various data types. So let us see what is the data type and what are the various data types in verilog. So basically data type is nothing but it is a classification which specifies which type of value can be assigned to a variable. That means, for example, you are taking some variable a and you are assigning a value of 4 to it, like a equal to 4. Okay, so in this what is happening means the a should be capable of holding the value 4. Okay, let me make you some more clear for this. For example, I am taking a equal to some 3.70. Okay, that means I am taking the real number, and if you are taking the real number then you should assign the data type for a which could hold the real data type, like for example real number. For example, if you are giving a as integer, that means a could hold only integer values, it couldn't hold the real values. And if you want a to hold real values, then what you should do, you should give the data type for a which is suitable for real numbers. Like for example, if you are giving real a, then what happens, then a could hold the value of 3.706. Is it or not? Right, so this is like data type. So similar, so basically these are two types of mostly used data types in any language, like integer, real, okay, string. So all these are different kinds of data types. So in verilog, apart from all these things, you are having two more important data types, that is net and reg. So again in registers you are also, it is again categorized like registers, integers, real and time. Okay, so now let us see what is net and what is reg. Okay, so net is nothing but it represents the connection between hardware elements. So basically in simple words, net is nothing but it is just a connection between two sources. For example, when you are going to hardware connections, so basically when you want to connect two hardware like components, what are you going to do, how are you going to connect them? You are going to connect them by using a wire. Is it or not? Similarly, in software, like in coding language, when you want to connect two sources, there should be a way, right? When you want to send like data from one source to another source, how are you going to do it? You are going to use a data type called net. Okay, so in verilog, net is used in order to drive the data from one source to another. So that is why we will that is why we use net in verilog. Okay, net have values which are continuously driven on them by output of the devices they are connected to. That means, for example, let me show you a small example. See, let us see this small example here. If you see a, b and c, this is a small AND gate. Okay, so here whenever the values, like for example I am giving like a and b as 0 and 0, then what happens, the value of 0 0 it will be driven to this particular gate, and then it is given to the output like 0 into 0. Since this is an AND gate, the c value will be 0. Okay, similarly, for example, another value like I am giving 1 and 1, that then what again it is doing, this net is driving those values and then giving the output. That means the values are not stable here, the values are continuously driven from one source to another source. So that is why net is used to carry the values. Okay, it is used to drive the values, it doesn't store the values. That is the main difference between net and reg. Okay, net can drive the values, whereas register can hold the value. Okay, mainly that is the difference, like net is used to drive the values and register is used to hold the values. Okay, For this, I am just giving a small example. For example, let us consider we are in a house. Okay, so every house is having some tanker. Okay, water tank, let us consider water tank. So when this comes to water tank is used to store the water. Okay, but whenever you need the water, you don't go to water tank and dip the bucket and you take. Is it or not? What you will do, you are using the pipes in order to drive the water from tank to your particular place where you need water. Is it or not? So basically, in verilog, that tank acts as ridge. Okay, the water tank is nothing but it is the ridge, and the pipe which is used to drive the water is nothing but wire. Okay, wire or net, both are same. Okay, so basically the water tank is the ridge and the pipe is nothing but it is the wire. Okay, so in this way wire is used to drive the values and reg is used to store the values. Okay, so basically nets are declared with keyword wire. Okay, so net is no description. So basically in programming language, in this coding of verilog, we'll be using that net as wire keyword, net with wire keyword. Okay, so as I already told you, net means it is used to drive the values, so basically it cannot store the value. Okay, that is the main difference. Okay, and whenever the value is not driven, okay, that means whenever there is no value to drive for the net, its default value will be z. Okay, this is also one more important interview question, like what is the default values. Basically everything will be having its default value. Okay, so you should remember those default values in verilog. If net is not driven, that means if there is no value for the net to drive, then its default value is 0, sorry, z. Okay, so nets are 1 bit values by default. That means whenever you are giving value like, okay, wire a, if you are giving as wire a, then that a is of 1 bit, until unless you are increasing the width of the wire. You can increase, but by default it is of 1 bit. Okay, so and also again in net you are having subcategories, like it is having many more subcategories, like wire, I already told you wire, and w or try and supply 1 and supply 0. So basically these are subcategories in the uh, net data type, but mostly we'll be using wire itself. Okay, wire is the important data type, one of the important data type in verilog. Okay, and then, so let me give you a small example here. So see here, this is the example for how are we going to use a wire in verilog. So if you see here, I am using two AND gates. Okay, the first AND gate and second AND gate. First AND gate is having two inputs A and B, and the second AND gate is having the output that is from first AND gate. You see here, T1 is the output from first AND gate, and it is given as input for second AND gate, and the second input is a different one like C, and then Y is the final output. So if you see here, A, B, C are considered as inputs. What is input? Input means the starting which you are giving is called as input. Is it or not? Output means which we are getting from our circuit or else anything that we are designing, that is output. So between this input and output there are many intermediate connections. Is it or not? So all these intermediate connections will be categorized based on usage, on our usage into either wire or registers. So if you see here, ABC are the inputs, fine, Y is the output, good. And then if you come to the intermediate connection T1, okay, this T1 is there between AND1 and AND2. So where this T1 is going? So basically these are intermediate connections, and this intermediate connection, since it is only used in order to drive the value, like if you see here, A and B are having the values, and based on A and B values changing, the T1 will be changing. Is it or not? So it is not storing anything, it is just driving what and one gate is sending. So basically T1 is wire here. Okay, and then the logic and end module. So this is about wire. Why do we use wire? Okay, and then coming to one more example. So here we have already talked about this example in the previous session itself. So I'm writing some full adder logic by using two half adders. Okay, if you see here, this is my first half adder and this is my second half adder, and in my first half adder, okay, you are having some intermediate connections, and in the second half adder also you are having some intermediate connections. So all these intermediate connections like C1 and S, they will be coming in the category of wire. If you see here, this is wire. Okay, A, B, C are the original inputs, so they are inputs, and someone carries S and C out are outputs. So basically this is input and this is output. Whatever that you are connecting in middle, they all come under the intermediate connections, and they fall under either wire or reg based on the need of the particular intermediate connection. Got my point? So this is about wire. So reg, as I already told you, in the same thing. For example, if you want these intermediate connections to store, to hold the value for some particular amount of time, then they come under reg. If they are doesn't want to hold any value and they are just use it to drive, then they come under wire. That's it, simple. Okay, see here, in verilog register is a in verilog register is a variable which can hold the value. Okay, that means it can hold the value until some period of time. Okay, just it doesn't drive the values just like net, it is used to hold the value. Okay, see, it will retain the value until another value is placed on them. Okay, it doesn't store the value, it will hold the value. That is the difference. Okay, registers are declared by keyword reg. Okay, and coming to register default value, that is X, whereas coming to a wire default value, it is Z. Okay, in the register we have different classes. Okay, again register is categorized like reg, just like in net we are having wire, W and W or like that. In register we are having again subcategorized into reg, integer, real, time, etc. Okay, registers can be declared as, can also be declared as signed variables. We can declare them as signed variables. That means it can hold both positive values and negative values also. And I think you know like what is signed. If you don't know like what is signed and all, I have already talked about lexical tokens. In lexical tokens I have talked about the signed numbers and unsigned numbers. You can go check it out there. Okay, so as for now, the register can hold both positive values and negative values. Okay, so see the same in the same example, this is the same example that we used for wire also. So here the same, like 2 AND gates, T1, Y and all, but here I want this T1 to hold the value for some particular period of time. So that is why what I have done, I have place the T1 as reg, not as wire. So that is what, based on our usage, it can be used as either wire or reg. Okay, so these two are very important. Like I think you got the difference between what is wire and what is reg. And now the third thing is integer data type. I think you know about the integer and real. So whenever you want to store the values like integer values, then you can use the integer data type, and it is having the default value, it is default value is 32-bit. Okay, and then see here, like just like wire and reg can hold the values, but the default values are 1 bit, whereas integer data type default value is of 32-bit. That means when you are not mentioning the size, it is taking the whole 32-bit sizes. Okay, and then when you want to store the real numbers, you go for real data type. Okay, so this is about integer and real. And then you are having one more data type called as time. So basically time is nothing but whenever you want to see the simulation time. Okay, whenever you want to find at what period of time your particular output is going on, at what period of time the delay, for example where you will be giving some delays in verilog. Okay, so after delay, at what delay your simulation is going, and at what time your output is being done. So all this, when you want to see the time of the simulation, then you use the data type called time. Okay, for this you will be using the keyword called $time. When you are giving a $time in your code, verilog code, that means you can see the simulation of that particular line where you are using this $time. Okay, and its default width is of 64 bits. Okay, so this is like time, right? And then, so this is the example for various data types, like see module and end module. I'm writing a verilog code for module test bench. Okay, I have taken the three data types like integer, real and time. Okay, integer int a, real b and time tc. And here what I am doing is integer a. Okay, I am giving a 32 bit. Okay, 32 tick h, that means hexadecimal. Okay, that means this particular thing is hexadecimal, it will be stored in the hexadecimal format and it is of 32 bit wide. Okay, so this is my this is the value that I want to store in int a. If you see the int a is of integer data type. And then coming to real b. Okay, when this comes to real b, it is 0.1234567. Okay, it is just a real number. I want to store it in real b. And then after, if you see here, this is called delay. Okay, basically hash 20. When you want to give delay, you have to give it in the format of like hash 20. What how much time delay you want to give, you can give it, but you should use hash. Okay, hash 20 times c equal to $time. So as I told you, if you want to see the simulation time, you should give $time. Okay, now I'm going to display just like in C. You will be using printf in order to display everything. In the similar way, in verilog you will be using the $display. So $display int a, it is in hexadecimal format, real b in floating, and then time c. Okay, that means percentage t. Okay, int a, real b and time c. So then int a, real b and time c will be seen in your log file. Okay, so this is what the basic example of data types, right? So this is all for today. And if you like to my explanation, and if you want further videos like this, please subscribe to my channel. And yeah, thank you.